Hola, buenos días.
Good morning, everyone. Today, I wanna talk about the about what I did in my master's thesis, which has to do with the incorporation of microalgae as a technique of presentation for the restoration of seagrass. Okay, a little bit of context, like I actually mentioned, we do have the signals of aware of enteroprotic uh, there's a discharge of nutrients in combination with a few natural causes, hurricanes and herbivores, and the seagrass are actually showing signs of in the Caribbean, but specifically about the Mexican Caribbean, that as of 2014, together with sargassum, we saw the red tide that actually affected the coast. This caused the loss of the seagrass and changes of composition. We have an interruption in the area. There's change in the environment, and these are the first ones that actually populate this area. So after these rizophytic algae, the Halodurite, and then Styridium spiliform and Thalassium, this structure is the one that actually made me question if it was possible to actually include microalgae, microalgae in the restoration of a secret strategy. So I actually started to investigate and to research, and I actually found that the Halimeda ingressata actually has additional resilience of the seagrass when compared to when they're not present in seagrass of Valencia, and they actually quite anchored compared to other species of the same group, and it wasn't affected by the Wilma hurricane, so they're actually quite resilient to adverse effects. On the other side, we have the Alimeda, which is they're actually very good for seagrass, for their high tolerance and also for the quick colonization. And in this case, it was very important to have a tolerant size species to the turbulent environments. So my experimental design consists in actually placing a transplant of with ingressata and already and only transplants of Ilograntis from this algae. So this experiment was done in the northern part of the peninsula of Yucatan in the Mexican Caribbean, in front of a hotel that's called Upalas, which actually shows this anti-sargassum barrier. And this is very important because it's a source of main degradation and alleviates this effect. And this was the distribution of these parcels.
Pueden notar todavía los efectos del agua marrón. Bueno, la extracción y colocación de trasplantes se hizo en parcelas de 40 metros cuadrados y se estuvo.
40 by 10 meters, and we should place 90 transplants in each parcel. In the case of the algae, rizophytic algae, we should place three. At the east rather, which is the area where the waves actually come in, um, and and when the tide actually comes in strongly. So with the intention of protecting these elderly transplants, which did the monitoring for about 6 months. We actually assessed the transplants and the expansion of the rhizoma, and also the density of these. Well, it is also present in this. Mhm. So we also have to the result in the first 1 days, we actually saw I was quite happy because it seems that the Almira is actually precisely actually helping what we see in the presentation. You can see over here, it's above the average in the parcels with Almira. So, but this pattern actually changed in the rest of the months, and it's due to these images that we see over here. So the Rizophytic algae actually start to accumulate to those that actually by the effects of the hydrogenation and with the waves, and of course because of the position, that she started to actually have a constant turbulence that actually broke the leaves and de-anchored the transplant. So therefore, it was quite a complex their survival in these parcels of Alimeta. However, it wasn't the only factor that actually influenced their survival. We also have that in the southern part of my area of study was characterized by fine sediments, and it's in this area where she found a less rate of survival. The fine sediments actually provide a less rooting, and it's due to this situation that we saw in this low survival rate in this area. On the other hand, the extension of the transplant, it exceeded the parcels with the treatment of just Adaduli because the Adadulis that can actually survive through the conditions, extreme conditions provided by these rizophytic algae with constant waves or the tide, and they could not were not able to extend this we're not able to extend them. So in regards to the density, we actually see that at the general level, at the statistical level, we saw significant values, but I actually did a study individually. I did found significant differences between both treatments. Here, the interesting thing about this is that we need to ask ourselves if there's an additional effect by the rizophytic algae of Alameda towards the Adaduli. We have if there's some kind of competitive space, but since this was not my main objective of my thesis, I can't give you a clear answer right now. Now, a few conclusions and recommendations. Definitely, this effect that I see mentioned about the rizophytic algae was really unexpected, which really complicated to prove my hypothesis. It would have been different of actually placing these elevated transplants in another position, not with the intention of protecting against a tide, but rather as a of actually providing more anchorage to the sediment. So as you can see in the picture, or as a matter of fact, a bit more separate with this same position, but in such a way that it shouldn't really affect the first process of development of the adenoid transplants. Now, even with this, the moderate survival rate in all parcels was enough to generate a um, a seed pastures of adenolite. So these with Aramena, you can see that it's quite abundant at this microalgae, but it didn't really prevent actually generate or develop a complete prairie of this. So you can see the presence of this algae does not affect the development in in this case that the restoration should be successful. And like I mentioned about the fine sediments, I think that this is something that we need to consider because the granulometric interpretation of the areas we can actually deposit these fine sediments indicates it can also be deposit other material or matter could be actually deposited right there in decomposition. And in this case, since it's an affected site by sargassum arrival, so it does present some uh, some residue that the barriers and sargassum cannot take away. It allows it to find sediment, so it causes these limitation of light and also anoxic conditions due to the great amount of organic matter that's accumulated right there. And that's it. So thank you so much for your time. And I also want to thank everyone that were present in this project, which is my school, Samo, Palas, the hotel, and also my Seagrass lab. Thank you so much.